Hello. So these are the instructions for the It's All Uphill Interactive, which I've gone ahead and assigned to everyone. It's a fairly straightforward activity, um, but it's really easy to make a mistake if you're not careful. So I'm going to go ahead and provide these instructions. That way you guys get a good start and you don't have to redo any of your data collection. So we'll jump down straight off to the purpose. So the purpose is just to figure out how the angle on an inclined plane affects the amount of force and by proxy the amount of work that is done to pull a cart up an inclined plane at constant speed. And so if you scroll down to the procedure, you'll see that you'll use the virtual interactive. You get to pick one of the masses, press run trial. It will tell you the amount of force that's required to pull the cart up the ramp. And so you'll record that value. You will have to go and measure the displacement up the incline. One of the constants is always going to be the height. So the height will always be the same value. And then you guys just have to calculate the work. It's important to distinguish, right, that by definition, we're only going to concern ourselves with the force that is acting to pull the cart up the ramp. And so if the force and the displacement are in the exact same direction, then the angle between them would be 0 degrees. And so for each of these calculations, you're going to be taking the cosine of 0, which is just 1. And that's actually the biggest pitfall that people fall into. So let me go ahead and grab some sample data. I'm just going to go ahead and arbitrarily pick a mass of 4. And then you can go and you can pick whichever angle that you want to start off with. So let me go ahead and start with 30 degrees. We'll kind of take it from there. So here's our simulation. Let me go ahead and record the values. So we got 4 kilograms. So 4 kilograms. Let's make that a little smaller. Oops. This should go up here. I guess I can't read. And then let's go ahead and figure out what the force and displacement are. So we'll go ahead and run the trial. Okay, and tells us 19.6 newtons. So let's go back over here. Let's make a new table. Okay, and let's go ahead and put that in. So we got 19.6 is our value in newtons. And then we need to go and measure the displacement. So you'll see that they give a scale right here. And so each of these black tickers, the dark ones, is 20 centimeters. So starting from 0, which was where the back wheel was, we got 0, 20, 40, 60, 80, 100. So that's 1 meter, 20, 40, 60, 80, 200. So we have 200 centimeters, which is the same as 2 meters. So 2 meters would be our displacement. Okay, you can go ahead and you can format this however you want. Next, it would be important to calculate the amount of work that is done. So because going back to this right here, the force was in the same direction as the displacement, which was up the incline, you can go ahead and say force times displacement. So I'm going to go ahead and say 19.6 multiplied by 2. And that's going to give me an answer of 39.2. So the amount of work that's done is going to be 39.2 joules. Okay. And so hopefully that kind of gets you guys off to a good start. When you want to go ahead and switch the angle, don't pick a new mass, just go ahead and go from 30, go ahead and pick 40, and it'll reboot the simulation, pick 50, etc., etc., continue, and finish the entire data table. Now, once you guys finish collecting your data, you'll see that I've left a little note here. In the first part of the analysis, you guys are going to be expected to graph your data. So you're going to be graphing force versus angle, and then you're going to be graphing work versus angle. And so my note is you can either do this manually using the shapes feature. So the shapes are right here. You could go ahead and you could manually add some text boxes and some shapes. I would go ahead and zoom in. Let me show you as much as possible when you're doing this. Let me go back to fit. And then from there, you're just going to be answering the analysis questions. So number 2 just says describe how varying the incline angle affects the force. Try to go ahead and list the parent function if you can. Describe how varying the incline angle affects the work, if at all. Uh, when work is done by an applied object, the object's energy will change. In this interactive, does the work cause a kinetic energy change or a potential energy change? Like you described that below. And then very lastly, you're going to write a conclusion. Please, please, please be sure that your conclusion is written in complete sentences that answers these 2 bullet points and also satisfies the purpose and objective right here. As a reminder, the objective was to determine the effect of an angle of an inclined plane on the amount of force and the amount of work that is done on the cart. So I would say as long as you've answered that, then you would be very good. If you want to go ahead and format it as a claim evidence reasoning, that would probably be the best practice. So that's it. If you guys have any questions, as always, feel free to reach out over email, and we'll see you on the other side.